Next, we have ellipses. So, an ellipse is a set of points in a plane, the sum of whose distance from two fixed points, called the foci, in the plane is a positive constant. So, if we look at, we have two different types, right? So basically, if we have an ellipse, we have two foci. So focus 1, focus 2, right? If we have two, look at one point, the distance between both of these foci, right, when you add them together, should always be the same. So the sum of the first distance for this point should be the sum of the distances for the second points, or second point, right? All these distances should be the same. We could have another one, C1, C2, right? And that should also equal the sum. And we know this is all going to be some positive number, some number greater than 0. So, again, you can memorize the ins and outs of every little individual thing. I think these are probably the better ways of doing it. This is how I specifically do it. So if we have a horizontal ellipse, it's going to be x squared over a squared plus y squared over b squared equals 1. A squared over b squared, or x squared over a squared plus y squared over b squared equals 1. And so, of course, a horizontal ellipse is going to be on the horizontal axis. It's going to look like that. So the major axis is going to be the x-axis, right? The one that it's majority of it is on, the bigger axis. It's wider on the x-axis. If it's the vertical axis, basically we switch the a and the b. So it's a squared over x squared over b squared, plus y squared over a squared equals 1. And if we graphed it, the majority of it would be on the y-axis. So the major axis this time is the y-axis. So important, super important things when it comes to the ellipse. A is always bigger than B. So A is always bigger than B. And we'll actually see that wherever A is, whichever it's under, that's going to be what type of ellipse you have. If it's under the X, it's a horizontal. The major axis is the X-axis. If it's under the Y, if the bigger number is under the Y, then it'll be the major axis of Y-axis. So we're always going to talk about a center at 0, 0. We can do more, but we're just going to make it easy on you. So like we said, the vertices, right? The furthest points away from it. These come from the letter A. So that's going to be plus or minus A away from the center on the major axis. The foci are going to be the plus or minus C. So they're going to be plus or minus C on the major axis. So if we have a major axis, we also have a minor axis. So the minor axis, those endpoints are going to be where B comes into play, right? So we can say, see, this is going to be negative A0, A0, right? This is going to be 0A, 0, negative A. And then on this point, right, the endpoints of the minor axis are going to be the B. So 0B, 0, negative B. And likewise here, this is where the minor axis will be. So we've talked about A and B, but we've also mentioned C. How the heck do you get C? Well, you do it by this. So we know that B squared is A squared minus C squared. So we can just solve that and figure it out from there. All right. Now, remember, A is all about the vertices. C is the foci, right? And for an ellipse, we know that the vertices are further away from the center than the foci, right? So it makes sense, since we're needing a positive number, we do the vertices minus the foci, a squared minus c squared. That'll come back into play in the next lesson. So easy way, hopefully, to remember it. All right, so when graphing the ellipses, these are going to be super easy, kind of like the circles. So first we want to convert the equation into our format, mostly by making the equation equal to 1. So you want the entire equation equal to 1. So a lot of times we'll just divide by whatever we need to divide by. All right, so then we're going to plot. So we need plus or minus a. Again, that's going to be on the major axis. And then plus or minus b, we said was going to be on the minor axis. And that's it. So let's look at some examples. So sketch the graph of 2x squared plus 9x or 9y squared equals 18, and then find the foci. So remember, we need everything to equal 1. So since it equals 18, we can just divide everything by 18, right? So when we do that, we end up with x squared over 4 plus y squared over, oh, not 4, 9, my bad. Y squared over 2 equals 1. So we need to know what a is, we need to know what b is, we need to know what c is. So out of these two, we see that this number is the bigger one, right? So then this has to be a squared. So then a, since it's positive, is going to be 3. Since 2 is a smaller number, 2 is going to be b squared. So then b is going to be square root of 2. All right. So just to graph, if we're just graphing for now, we'll find the foci in the second. All right. So we see that the a is underneath the x, right? So we go 3 on the x-axis, square root of 2 on the y-axis. So 1, 2, 3. 1, 2, 3. And square root of 2, that's going to be between 1 and 2 somewhere. Same thing with negative. So this is what we get for the ellipse. Now, let's check out the foci. So remember, we said that for the ellipse, the vertices are further away. So A is further away than C, the foci, right? So we got a squared minus c squared. So we said b squared was 2, c squared was 9. All right, so we can pretty much see that c is going to be the square root of 7. So the foci, right, are going to be on the x-axis. So the foci are going to be plus or minus the square root of 7, 0. And that's it. All right, let's do another one. So, once again, we want to divide everything by 25, so we need it to equal 1. So we get 9x squared over 25 plus 4y squared over 25 equals 1. But this doesn't necessarily look like our format because we have numbers in front of the x squares and the y squares. So instead, what we can do is we can kind of undo a complex fraction, right? So just bear with me, but basically we can put this underneath our denominator as a fraction. So this is going to be the same as x squared over 25 over 9 plus y squared over 25 over 4 equals 1. And let's just check to make sure that works. So we got x squared divided by 25 over 9, right? So that's x squared divided by 25 over 9. The way we divide fractions is by multiplying the denominator, multiplying by the reciprocal of the denominator. So we end up with 9x squared over 25, which we saw is exactly what we did, right? So, like we said, basically we can put that coefficient in the denominator of the fraction in the denominator, right? We can make the denominator a fraction itself. And so this is how we can do it. All right. So we got to ask ourselves, which one's bigger, 25 over 9 or 25 over 4? So hopefully we all see that the 25 over 4 is bigger, right? That's going to be cutting it up into bigger chunks, essentially. So we see that that's going to be the a squared. So a is the square root of that, which is 5 over 2. Likewise, b squared is going to be the 25 over 9, which means that b is 5/3. So if we graph this, right, we see that A is under the Y, so we're going to go up 5 halves, or 2.5. So 2.5, 2.5, right? And then on the x-axis, we're going to go 5/3. So it's just shy of 2. So this is a vertical asymptote. To find the foci, remember, we're going to do b squared is, the vertices are further away than the foci, so we're going to do a squared minus c squared. So b squared, we said, was 25/9 equals a squared, which is 25/4, minus c squared. So hopefully we can see that it simplifies down to c being 125/36, which means that c is 5 square root of 5/6. Which means that the foci this time, since it's on the x-axis, right? We know somewhere on the x-axis, it's going to be 0 plus or minus 5 square root of 5/6. All right, so let's go backwards. So now let's find the equation of the ellipse with the vertices at plus or minus 4 and the foci at plus or minus 2. So if we want to draw it out, right, we know it's going to look something like this. Now remember, when we say vertices for an ellipse, we're thinking A. When we do foci for an ellipse, we think C. That's a little different from, for instance, a parabola, right? Parabola focus, we think of A. But in this case, for an ellipse, A is the vertex, C is the foci. So all we need to do is find our C and B. And first thing we can do, right? We can already see that since A is under the X, right? X is the thing changing. We're going to see it's an X squared over A squared scenario. So now we just need to figure out what B squared is. So B squared, we said, is A squared minus C squared. The vertex is further away than the foci. So we get 4 squared minus 2 squared, which is 16 minus 4, which is 12. And we can't go all the way down and figure out what B is, but we don't need to, right? The only thing we need to do is figure out what B squared is. So we're basically done. So we know that our equation is x squared over 4 squared, right, which was 16, plus y squared over 12 equals 1. And that's our answer. We're done. Didn't ask us to find anything else. And we can double check, right? We know that the bigger number should be under the x, and it is. So probably did it right. All right, this time, find the ellipse with the vertices at plus or minus 13 that passes through 6, 5. So we see this time, vertices, we think of the letter A. A is the only thing that's changed in this is the y value, right? So we're going to see it's x squared over b squared plus y squared over a squared equals 1. And we can actually already solve for the a squared, right? That's going to be 13 squared, which is 169. So now we just got to figure out what b squared is. Well, thinking about what b squared is, right? This time we don't have vertices, or we don't have any foci, we don't have the endpoints, we don't have anything like that. So instead what we could do is we could just plug this point in, right? Here's an x value, here's a y value. So we plug all that in, we'll be left with our b. So we get 6 squared over b squared plus 5 squared over 169 is 1. Which means that we get 36 over b squared equals 1 minus 25 over 169, also known as 144 over 169. We can definitely cross multiply it here, right? Get 144b squared is 6,048, or 84, excuse me. Which means that b squared when you simplify it down, is 169 over 4. And again, we didn't need to know anything else. That's all we need to know. So if you plug it back into your equation, oh, not that equation, the original equation. All right. There we go. We can see that it's x squared over 169 over 4 plus y squared over 169 equals 1. And this is absolutely the answer. If you put this on a test, I'm counting it right. However, if you want to make it just look a little prettier, right, you can move that 4 up to the top. And so you can have it as 4x squared over 149 plus y squared over 69 equals 1. So either way works, but this way definitely works as well. All right, that was it. Hopefully this was just a quick review. You've already seen this, hopefully, in college algebra. But as always, if you have any questions, let me know.